Hello all. Today we are going to see about quick sort used in data structures by Python language. So let's see what is quick sort. Quick sort is nothing but it's a sorting technique. Okay, it's in place sorting technique as we sort the arrays which are elements located within the array. So it's in place. It's not stable. It's as we saw merge sort. This is also divide and conquer approach only. It's capable of sorting a list of data elements significantly faster than any of common sorting algorithm. Yeah. Uh, in all of the sorting algorithm, quicksort is the most fastest. So only it's named the quicksort as it is in the line. It is also one of the most efficient sorting algorithm. Okay. Let's go to the working. It is before going to working. It's also called as partition exchange sort because partition is the main objective we are going to use in this quick sort. See here, partition one value lesser than pivot. Pivot is the first value, first value of an array. So pivot partition one value less than pivot, partition two value greater than pivot. So there are two conditions here. Let's see the working and we can see about this we will understand. Array is divided into two subarrays by selecting a pivot element. Okay, array is divided into sub arrays by selecting a pivot element. Okay, first by selecting pivot element array is divided. Okay, while dividing the array the pivot element should be positioned in such a way the element lesser than pivot are kept on left side and elements greater than pivot are on right side of the pivot. Yeah, while choosing a pivot we have to be sure that some elements are lesser than pivot should be placed on the left side while the greater element should place the right side of the pivot in an array. So the left and right subarrays are also divided using the same approach. This process continues until each subarray contains a single element. At this point, elements are already sorted. So conquer. Finally, elements are combined to form a sorted array. This is the main point here. The left and right subarrays are also divided using the same approach. This process continues until each subarray contains a single element. As we saw in second point, whatever number first we choose as a pivot, the elements lesser than the pivot should be on left side, while the elements greater than pivot should be on the right side of the pivot. So same as this first step is done, next step also we are going to divide the left and right subarrays using the same approach until the each subarrays contains single element. So while single element we get elements are already sorted, which is conquered. So elements are conquered after at last combined method. So all the elements are combined. We already know in conquer itself the elements are sorted. So in combined, just we are sorting the elements in an array. So our combined method is over here. Yeah, there are many different ways to pick pivot element. Always pick first element as pivot, or always pick last element as pivot. Pick a random element as pivot, pick median as pivot. So there are four methods we can choose a pivot. Coming to algorithm, we are using a partition function as we saw. We have to part the array into subarray pivot and left side lesser element, right side element. So we are using partition and pivot I'm choosing. Starting point and ending point I'm giving. So these are the algorithms. After this condition over, I'm just swapping each elements lesser than or greater than to pivot. So these are all we can see in the program. Before going to program, we can see time complexity. Best is O log n, O n square log n. Worst is O n square. Average is O n per log n. Space complexity is O log n. This is the time complexity as the big sort because when pivot is middle element or near to middle element, it is best. When pivot element picked is either beginning or end element, the complexity will become worse. So O into as it becomes harder to sort the array, this is the worst complexity. This is average complexity, while this is the space complexity because it is recursive. We already know logarithm n is recursive and no need of extra space. Uses stack only. So space complexity is O log n. So we can go. We can see this algorithm elaborately. We can go to program This is our program. First I'm creating quick sort function and I'm checking last and first. Last minus first greater than 1, that is last element minus first element index should be greater than 1. That means a is assigned to a variable is equal to partition list first and last. This is list and this is the first element and last element. So quicksort the elements we are checking. So you quicksort list a plus 1 last. So these are the point I am checking in quicksort. Just is nothing but I am checking the last element and first element, it is greater than or 1 or not. After comes 1, I am assigning those variables. That's it. So quicksort is over. This main function is over here. Next we are going to partition function where we are choosing a pivot. Here I am giving pivot as first element because yeah, we can give any element as we saw in the condition. There are four conditions. Either it can be first element, or either it can be ending element, either it can be middle element or a random element. So I'm giving first element. I is equal to first increment 1 plus 1 and last is minus 1. We know the index values only. While true, while I is lesser than or equal to j and list I lesser than or equal to pivot. Main condition here, I is equal to I plus 1. As I is lesser than or equal to j and I is also lesser than pivot. So we know that the lesser side element to be present uh, to left side of the pivot. Okay, so I plus 1 as we choose our first element. I am giving a plus 1. Finally, coming to uh, list j greater than pivot, we know that I choose to pivot as first element. So I am giving here minus 1 as the last index is starting. So j minus 1 I am giving. We can understand here. And if I lesser than or equal to j, list j is equal to list j, I am assigning I to list I to list j and list j to list I respectively. Else uh, suppose if this condition goes is not applicable, or our elements is not conjoined with this condition, I am using list first, list j is equal to list j, list first. Okay, list first I am assigning to list j and list j I am assigning to list first if this condition is not conjoined to our elements only. So at last our partition function is over. We parted every elements. We have conquered and combined in this algorithm. We saw everything we are assigned. So I'm entering the values in the list and getting everything. That is len is I'm counting the list. So I'm printing the sorted list. The sorted list. Okay. This is just printing elements. That's all. So I'm entering the values in the list. I gave 6 values: 12, 36, 17, 45, 34, 38. See here, I enter the values and I'm getting the sorted list is here: 12, 17, 34, 36. Yeah, this is sorted in a sorted manner. As we know here, I chose my first element as pivot, so it will be stay as it is. It checks the next element only. If I is lesser than or equal to j, or I is greater than or equal to j, same way it check every elements, compares every element in the list, and by conquering second method, it conquers each element. It will be single single, and finally third method is combine. While combining, we get the shorter method. So our sorted list is here: 12, 17, 24, 36, 38, 45. Yeah. So the quick sort is successfully implemented and the values are also sorted respectively. So it's nothing but coming to quick sort. First basic algorithm here is quick sort function, as we are giving parameters such as list first and last we are mentioning. Then secondly we are doing the partition element. Partition method only I get the pivot and I check whether the value of I and j are greater than or equal to j and I respectively. So I'm giving everything in the list, and third step I'm getting the values in the list, and fourth step I'm getting the sorted list. So this is also divide and conquer approach as we saw in merge sort. So this is our program. Yeah, we got the result. Over. Thank you.